Find the area of the region under the graph of f on AB. So let's look at here. We have a graph y equals fx, and the area under the graph from A to B, pretty much inside this, above this x-axis, this area, which is given by this definite integral. Just find the entire derivative of fx and evaluate from A to B. So in part A, we have the function fx equals x squared minus 2x plus 2, a, b, so negative 1 to 2. So using this area formula, then the area is negative 1 to 2 of x squared minus 2x plus 2 dx. Okay, so we just evaluate this integral. So we find the entire derivative of x squared, 2x, then 2, and evaluate at upper limit minus lower limit. So entire derivative of xn, we know the formula for xn dx, that's xn plus 1 over n plus 1, as long as this is not 0. So n is not equal to negative 1, and that's x squared. So x 2 plus 1, 3 over 3, minus 2, just leave 2 as it is, times x means x raised to 1. So x 1 plus 1, 2 over 2, and by the way 2 and 2 cancel, just x squared. Or if you know entire derivative of 2x is x squared, then you don't have to show this work, because we know that derivative of x squared, okay, derivative of x squared is 2x. That means entire derivative of 2x is x squared. Okay, so the second plus entire derivative of 2 is 2x. So entire derivative of constant is constant times x. Plus c is not needed. Now we want to evaluate this from negative 1 to 2. Okay, so replace x throughout by 2 minus replace x throughout by negative 1. So let me erase this and I'll come back. Evaluate this at upper limit 2. So 2 cube 8 thirds minus 2 squared 4 plus 2 times 2 4. So here is minus lower limit, that's the upper limit minus lower limit. Evaluate this function at negative 1. Negative 1 cube is negative 1 third minus negative 1 square is positive 1, so minus 1, plus 2 times negative 1 is negative 2. And we can see negative 4 and positive 4 cancel. Okay, negative 1 minus 2 is negative 3, and we need to distribute this negative. So this is 8 thirds upper limit minus minus, it will be plus 1 third. This is negative 1 minus 2, negative 3, and distribute negative, so positive 3. And we can combine these two fractions, 8 thirds plus 1 third, 3 3 3, 9 thirds, which is 3 plus 3, 6. So the area under the curve is just 6. Now let's do the same thing for part B. So from A to B, the function, given function. Now let's evaluate this integral. So 1 over x squared, we don't have fraction rule, so move this to the top, which is same as x raised to negative 2. And we can use the power rule for this n not equal to negative 1. So this is x n plus 1 over n plus 1. So x negative 2 plus 1. Negative 2 plus 1 is negative 1 divided by the same thing from 1 to 2. This negative can be pulled to the front. X raised to negative 1 is 1 over x, by the way. Okay, now we need to evaluate from 1 to 2. Now we plug x equals 2, upper limit minus lower limit. So upper limit negative 1 over 2 minus, that's from the fundamental theorem of calculus formula, minus lower limit minus 1 over 1, which is 1. So we have negative 1/2, negative negative positive 1, and 1 minus 1/2 is just 1/2. Final.